Hi, so this is just a quick video going through the resources I created for the PN4036 final lab portfolio. In this video, we're looking at the underlying principles of each of our primary conic sections, which are the ellipse, hyperbola, and parabola. Firstly, we're going to look at the simplest of the three, which is the ellipse. It is here on screen. So each conic section is formed by a cutting plane, and that is indicated here by the light blue line traveling through the cone. Moving on from that then, how we find our actual conic section, so our ellipse up here. If we look at the cutting plane, we have the entry and exit points of our cutting plane to the cone, which give us our vertex. So where we find this point here, for example, intersects with the outside of the cone, gives us a line which is projected up to our new view up here, giving us our vertex. And it is the same then for the bottom vertex, so it's the two most extreme points that the cutting plane touch in our cone. Following on from this then, we have to find our focus, our directrix, and also our focal spheres and justify them. So if we look at the focal spheres, first of all, the focal spheres are a sphere which are tangent to our cutting plane and also a tangent to the cone itself. So this focal sphere has a tangent just here, and also it is tangential to the cone itself along this line. So this line is the line of intersection between this minor focal sphere and the cone itself. So that line of intersection then gives us our directrix up in our auxiliary view, and the same for the larger focal sphere at the bottom. So again, the line of intersection between the focal sphere and the cone gives us a line here, and once it hits the cutting plane, it's projected up and gives us our directrix. And finally then, all we need to find is our focus. So our focus travels straight through the midpoint, travels at perpendicular to the cutting plane, and once it hits our axis again, we have our focal point of our ellipse, and it is just the reflection of it up here, also the center point of the sphere in the minor focal sphere. So that gives us the important points, and all we're missing then is the length of the minor axis. And the easiest way to find that is to find the center point between our two focuses or our two vertexes. And all we need to do then is find this distance here, so from this point to our vertex, which is half the major axis, and then strike it off from our focus, giving us this line here, and where it intersects with our minor axis will give us a point, and that is the most extreme point on the ellipse to the top, and it is the same distance then to the bottom. So that is all the key points required to create the ellipse, and as required then also, this model view is completely interactive and it's dynamic, so we can move this, giving us different ellipses as we move, and the text also updates accordingly. So as you can see, it's far more circular in shape here, as the cutting plane is almost parallel to the base, and I can move it back down like so to make it a bit larger, and I can also drag the whole cutting plane downwards or upwards to change the shape of the ellipse, but it ultimately stays at an ellipse no matter what orientation I change it to. Moving on from the ellipse then, we shall look at the next dynamic model which I created. So it is the hyperbola or hyperbola. The hyperbola then always cuts both the top and the bottom cone, as you can see here, and its line of our cutting plane rather is always either perpendicular or relatively close to perpendicular to the base of the cones, or else you could say parallel to the axis. So our principles then which underpin this are relatively similar to the previous principles. So the same goes for the directrix. It is the tangent to the cone. So our focal sphere and our cone are tangential, and where they intersect is the line of intersection here, which is transferred out to give us our directrix. The same goes for the vertex also, so it's the most extreme point on the outside of the cone, so it's this point here, transferred across, giving us our vertex, and it's the top of the conic section. And the same also for the focus, which travels directly through the center point, travels out, and hits our axis, giving us our focus. So they're the key points needed then again for our hyperbola. And the another key difference between the hyperbola and the ellipse is that it ends at the base. So we have this horizontal line, which is corresponding to the base. So it's the width of the hyperbola at the base of the cone. So that's the key principles which underpin the hyperbola. And as required also, this is a dynamic model, so it can move in like so, and also the text updates as required to make it clear as possible for the student. So as you can see, I'm moving it in and out there, and without issue it'll update on the outside, giving us our many different hyperbolas as required. Finally then we'll look at the final dynamic mechanism which I created. So this is the parabola. The parabola again has pretty much the same principles as the other two. It, like the hyperbola, it only has a single focal sphere per conic section, unlike the ellipse which has two. And also the corresponding points, so the focus, vertex and directrix are formed in the same way. Focus is straight through the center point of the focal sphere. The vertex is the most extreme point on the cutting plane, so the top point here corresponds to the top point up here, which gives us our vertex, and our directrix then is where the horizontal line of intersection between the focal sphere and the cone itself hits the cutting plane and goes perpendicular again to give us our directrix up top. The principle then which gives us our actual parabola shape is that the parabola's cutting plane is parallel to the outside of the cone. So like so, you can see this line and this line are parallel. And as required also, this is a completely dynamic. So we can move this cutting plane in and out as required. It doesn't seem to be moving for me, but it can be done. And you can do that with the model itself. And finally then, as an add-on to this final dynamic resource, I created another just finishing resource to it, and as you can see, I created the dynamic mechanism so that it would reflect what the cutting plane itself would look like and what the cut surface would look like. So here now we have what the cut surface would look like if our cutting plane was actually carried out on the conic section, or the cone rather, and this is the conic section that we formed, a parabola. And then if we were to create the true shape, this would be the true shape of the parabola or the cut section, and we would just omit this section down here as it would be completely gone from the cone. So all this area here would be gone from the cone, and that would give us our true shape of our cut section. So that's it for the dynamic mechanism and dynamic models, and the rest of the information is in the submission itself. Thank you.